Hi Chem team. You guys know that the elements on the periodic table are arranged in order of number of protons, with hydrogen just having a single proton in the upper left-hand corner, and each element thereafter increasing by a single proton. But the rows and columns of the periodic table are determined by an element's electrons. For example, the horizontal periods on the periodic table show the number of electron shells that an atom has. So elements in this first period, hydrogen and helium, each only have one shell of electrons, whereas elements in the second period, lithium through neon, have two shells. Elements in the third period have three shells, on down through the seventh shell of the periodic table. Each vertical group on the periodic table shows us how filled up those valence shells of electrons are. So elements in group 1 just have a single valence electron. You can see that hydrogen has just the one valence electron in its outside shell. Same thing with lithium, just one electron in its valence shell, and sodium as well. Group 2 elements, meanwhile, have two electrons in their valence shells. You can see beryllium has just two electrons in its outside shell. Same thing with magnesium. And group 3 elements each have three valence electrons. Group 4 elements each have four electrons in their valence shells. On through to the halogens, which each have seven valence electrons. And last but not least, the noble gases, which have completely filled up and stabilized their valence shells. And in general, what you'll see is that most atoms do need 8 valence electrons to fill and stabilize their valence shell. We call this idea the octet rule. A couple of exceptions would be like hydrogen and helium, which only have one shell that only needs two electrons in order to fill and stabilize it. So if a chemist wants to show the valence shell of an element to show how close it is to being stable or how far away it is from being stable, they'll create something called a Lewis dot diagram. So for example, if a scientist wanted to show that argon had a completely filled valence shell, they could just draw the chemical symbol for argon and then just draw 8 valence electrons around it. Meanwhile, if a chemist wanted to show the valence shell of nitrogen to show how close nitrogen is to being stable, they'd find nitrogen in the 5th group on the periodic table, which means that it has 5 valence electrons. And they would draw its chemical symbol and they would write in 5 electrons around it to show that nitrogen would still need 3 valence electrons to fill up its valence shell and become stable. And that's it. At this point, you guys have a couple of practice problems. We'll see you in class tomorrow.